I'm Anil Kumar sharing with you a test question from calculus derivatives. The question here is, sketch a possible graph of a polynomial from the following information and then determine its equation. So the information given to us is about the intervals and how does the first derivative changes during this interval. So we are given that in the interval from minus infinity to minus 4, it is positive. At minus 4, it is 0. From minus 4 to 1.5, the first derivative of the function is negative, right? So this is negative, and let me put them in brackets. It makes more sense. Okay. And then at 1.5, it is 0, and then again it's positive at 1. During the interval 1.5 to infinity, right? So that is the information given to us. What we really need to figure out is to sketch a graph of this function and also find its equation. So that's the question, right? Okay, so let's analyze this a bit. This really means what? When we say the first derivative is positive, that means the function f of x is increasing, right? So it is increasing. Okay, and this is a turning point, and here it is decreasing. Negative, right? Negative means decreasing. This is also a turning point, and this it is again increasing. Okay, now some of you may like to do like this. Increasing means going up like this. Decreasing means going down like this. Increasing means going along this, right? Now from this you really get a very good look that this turning point, because it increases and goes down, happens to be the maximum, right? And this turning point is from decreasing to increasing, should be a minimum. Is it okay? So that is how we analyze the first derivative. So we analyze the first derivative to find maximum and minimum. So we know that a polynomial under consideration has maximum at minus 4 and minimum at 1.5. Now it becomes simpler for us to sketch. So what we'll do here is we kind of sketch it. So we let's say 1.5 minus 4. Let's say this is my y-axis somewhere here. Okay. So I'm just making, as usual, very rough sketches, but accurate enough to understand the concept. Okay. Now the idea is that we have a maximum at this point, minus 4. Let's say this minus 4 is here. Okay. So let's mark these points a bit. Approximately, we'll do this job. So minus 4, we'll say minus 4 is here. 1.5 is somewhere there. So somewhere along this line, we have a maximum, and somewhere along this line, we have a minimum. Once we sketch our polynomial, then what we can do here is that we can write its equation, right? So somewhere here, so we could just sketch a polynomial like this, right? So we could do a rough sketch here. I want to use a very light color. So we could say that the polynomial could be like going like this. It may go through the origin, because we want to write equation of this polynomial also. Do you get my idea, right? So you could do a graph like this, and you may go through or let's do a general graph. You would go like this, maximum, and somewhere here you turn back. Well, you get an equation, a graph, but writing equation will become difficult. So sketching a polynomial is not a difficult issue. You could do that. But however, you'll find that writing equation is difficult. So now the question is, how to sketch and write equation. That is huge. So you have to write equation of the graph which you sketch, right? So why not keep it simple? So let's keep it simple. Key issue, keep it simple. Do you understand what I'm trying to say? Keep it simple, right? So what I will do here is that I'll sketch a graph which you'll find so amazing. We want to make a maximum here, so I'll say let this be the maximum, who cares, and let this be the turning point also, and then we'll just go down, right, and then we just turn from here and then we go up, okay, and we say this is my, because well, let me just push this a bit, minimum, right, and that's my maximum. So my maximum here is at -4, minimum is at 1.5, right? The values are given to us already. If not, we'll just choose this value. We'll choose this value. However, I'll choose this value, right? So let me take this value as, let's say, -4. Okay. So I've got a sketch of a polynomial which has a turning point at -4, which is also a maximum, and then it has a turning point at 1.5 with some negative value, which I don't care about. However, it is a minimum as given in the condition, and has a y-intercept which is -4. So if I sketch this graph, I'm able to write an equation. So that's the idea. Keep it simple so that you can write the equation, else it is going to be a tough question to answer in the test paper. You get my idea, right? I'm Anil Kumar, and I hope you appreciate this part. Okay, so let me write down the equation of this function. Let me call this as f of x. So we say f of x is equal to a times, this turning point is at -4, so x plus 4 whole square, and this turning point is at 1.5. Okay, so which I cannot really use in this particular graph, right? But we don't know what this x-intercept is. So what I'm assuming here is, let this x-intercept be, we can define this point, is it okay? Let this x-intercept be at 3. Do you get an idea? So as soon as I put that, then I have this as x minus 3, my factor. Is it okay? So x minus 3 becomes 1 factor, and this turning point gives me a factor with order 2. To find a, I could use my y-intercept. So that's my graph, okay? That's my graph. So if I use -4 here for, as my y value for x equals to 0, I may get some value for a, right? So let me use that. So I just took some general points. So f of x is -4 equals to a times x is 0, that means 4 squared, and this is -3. Is it okay? Substituting x equals to 0. Is it okay? So one of these 4's cancel out. Is it okay? One of these 4's cancel out, and what I really get here is that a is equals to 4 times 3, 1 over 12. Is that okay? So if you could see, this implies that a, when you solve this, is minus cancels out, correct? So 4 times 3, 12. So you can write 1 over 12. Is it okay? So with this result, I get my function f of x as equals to 1 over 12 times x plus, 4 whole square times x minus 3. Do you get an idea? So you could actually graph a simple graph like this and then figure out an equation, provided you use this information in a useful way, right? Some of you can do something like this. You could have a minimum at this point, right? So let me give this as a question for you. So what I'll do here is that I'll just shift this up, kind of, okay? So I'll shift this up. We could even, because this interval is increasing, do you see increasing interval, right? And then it is decreasing and then increasing. It all fits in. So what I will do now here is draw another graph. However, the turning point is somewhere there, but I want to make the other turning point right there. So what I'll do here is that I'll just bring it down kind of like this. Not so neat. However, this gives you the point. Is it okay? So that becomes my polynomial. Correct? So this is the turning point. This is the turning point in the question, and that one I made as my 0. Correct? And this, let this be the x-intercept And let me write down the value for this. When you graph, you can see the value, but you could say, well, let this be 5 minus. So if this point is 5 minus, then you get a polynomial whose function should be a times. So this is linear 0, x plus 5 times. This one is at 1.5, x minus 1.5 whole square, since it is turning. And then you, of course, can find the y-intercept from your graph, give it a value, let this value be, let's say 2, okay, and then find a. You get an idea. So from the graph, whenever you sketch a graph, you'll get these values, whatever it is, use those values and get the equation. So what I'm suggesting here is that one of these critical points should be used as zeros to find easy solution or easy equation of the polynomial. That is the suggestion which I'm making in this video, and I hope it helps. I'm Anil Kumar. You can always share and subscribe to my videos, and feel free to post your suggestions. Thank you and all the best.